NASA's Jet Propulsion Laboratory presents the Von Karman Lecture, a series of talks by science engineers who are exploring our planet, our solar system, and all that lies beyond.
Hello, everyone, and a very chilling evening to you, wherever you may be. Welcome to another remote edition of our Von Karman series. I am Brian White from JPL's Office of Communications and Education. This is Galaxy of Horrors. Tonight's talk will delve into the mysterious and terrifying phenomena throughout our universe, reminding us how lucky we are to live on planet Earth. There are only a few things that keep us up at night. These are only a few of them. This is not everything. But if you have questions on the mystifying and horrifying aspects of astrophysics and exoplanets, we urge you to be involved in the conversation. If you're watching on YouTube or Facebook Live, ask questions in the chat box, and our diligent social media team will bring in as many as we can throughout the night. Now, if you don't see the chat box, go ahead and reload your page, and it should be right there. And on that note, we ask if any technical issues do arise, you just stick with us as we get them sorted out. Now, at the end of our show tonight, we're going to play our Galaxy of Horrors video, made in the style of a classic monster movie trailer, so make sure you stick around for that. Helping us with questions tonight will be public outreach specialist Thalia Rivera. Hiya, Thalia.
Hi, Brian.
You know, I understand the Galaxy of Horrors, this whole series is something very close to your heart.
It is very close to my heart. I actually produced this poster series last year with the help of some amazing artists and experts in the field. And I was inspired by Halloween to highlight the terrifying real worlds that exist in our galaxy. Since the inception of the series, we have begun to look at other mysterious entities in the universe, though. So be sure to check out our website, exoplanets.nasa.gov, later this month for a real treat and to learn more about our Galaxy of Horrors. As a reminder, we will be answering questions later on, so please be sure to pop your questions into the chat on Facebook and YouTube, and we will get to as many as possible. Now, I think it's time we get this show started. Brian, back to you.
I think it is. We do have quite the panel of mad scientists with us tonight. So first up, an astrophysicist at JPL and the project scientist for NASA's New Star satellite, which observes X-ray emission from some of the most extreme energetic phenomena in the universe, such as black holes, neutron stars, and supernova explosions. He currently holds the record, and I love this, he holds the record for having discovered the most distant black hole known, detected when the universe was less than 700 million years old, or just 5% of its current age. 700 million years old, just 5% of its current age. Here to talk about ghastly galaxies, it's Dr. Daniel Stern. Hi, Daniel.
Hey there, Brian. I'm very happy to be here.
What do you got for us tonight?
Yeah, hi. I'm very happy to be here tonight. I'm going to talk to you about one of the things that keeps astronomers up at night, a little scary thing that's coming in our future. I'll add the little caveat that astronomers like staying up at night. That's our usual job. And this scary thing that's happening, it's about 4 billion years from now, so nothing to really be worried about. But we are heading towards a collision with the nearest large galaxy to us, the Andromeda Galaxy. And here's a little graphic showing that. About a century ago, using Mount Wilson Observatory, which is just above the hills of Pasadena, you can see it on clear days from down here. So about 100 years ago, Edwin Hubble realized that galaxies are all moving away from us, and the speed that they're moving away from us is proportional to how far away the galaxies are. And that taught us that the universe is expanding, taught us about the Big Bang. It taught us that there's these weird things in the universe, like dark matter, dark energy, that Jacqueline's going to teach us about in a little bit. But the one big exception to that, all the galaxies are moving away from us, is the nearest big galaxy to us, Andromeda, is actually moving towards us. It's coming at us about 70 miles per second, so pretty fast. Though kind of slow for an astronomer, but anyhow, it's moving towards us. And this collision is going to happen in about 4 billion years. So go to the next slide. So here is a computer simulation of what that collision might look like. There's the Milky Way rotating around. Zooming in, we're going to pan out, and you'll see that the Milky Way is a pretty flat galaxy. Andromeda, that's coming in on the lower right now, is also a rather flat disk galaxy, a little brighter in the center. So these are two disk galaxies, very similar. Andromeda is a little bit bigger than the Milky Way, we now think, and they're coming towards each other. And this is a slow motion collision. It's going to take a couple billion years, but then we'll kind of slam through each other. And galaxies are largely empty space. There's just, even though there's 200 billion stars or 300 billion stars in the Milky Way, and a slightly bigger number in Andromeda, there's just so much empty space that the stars won't really collide, but the two galaxies will pull through each other. The gravity will pull them towards each other, and we'll end up in about 7 billion years as a sort of merged single galaxy, more elliptical shaped than disky or flat. And so this is from a press release out of the Space Telescope Science Institute a couple years ago. We can go to the next slide. And the big result from their work that this press release was reporting on is that we knew from Hubble's day a century ago that Andromeda was moving towards us, but using Hubble, they were able to see the transverse motion to see whether it was going to go by us or slam into us. And using Hubble and careful measurements over a decade, they were able to see that we're pretty much on a head-on collision. And so what I love about this press release is they showed some images of the night sky over the next several billion years. And so this is a current day version. You see the Milky Way as that big swath that you can see on a dark night sky across the world. And then at sort of 11 o'clock, you see a little thing that's Andromeda, which you can see with your naked eye on a dark site. Let's go to the next slide. About 2 billion years from now, Andromeda will be much bigger on the sky as it comes towards us, and it will start looking more impressive. Next one, about 3.8 billion years from now, the Andromeda will be getting quite close to us and will look really beautiful in the night sky. But then the collision happens, and this is sort of like the car rolling over, and we're on Earth in the midst of this collision. Next slide, about 100 million years later, we're just like gas hits each other, stars start forming, and we're rotating around in these colliding galaxies, and it's a mess. Next slide, another 100 million years later at 3.9 billion years, the whole sky, we're in the middle of this big collision. Next slide, 4 billion years from now, where Andromeda's kind of moved away from us, and then it's going to pull back in. Next slide, 5 billion years from now, and you can still kind of separate out the Milky Way and Andromeda as we crash in together. And then the final slide, 7 billion years from now, and we're just in one merged galaxy. So kind of a big cosmic fireworks from this galaxy collision. One of the two things that, even though stars are unlikely to hit each other during this collision, the two things that are going to happen are stars will form, and that can create a lot of energy and supernova going off. And then the black holes in the center of the galaxies are likely to start feeding more, and we might turn into a quasar, which can put out a lot of gamma rays. But that's the ghastly galaxy collision that's in our future.
Well, that's going to keep me up at night, as you just said, but not in the fun. I'm going to look up at stars. That's something that I'm going to think about turning into galaxy soup there. Looks like there's a lot of questions coming in. So what's on our audience's mind, Thalia?
Yeah, so our audience would like to know a lot of things about what you just talked about, Daniel. But Dwayne on Facebook is asking, which will happen first? The collision of with the Andromeda galaxy and our galaxy, or the sun running out of fuel and consuming the Earth?
Great question, Dwayne. And they both happen on pretty similar timescales, just shy of 4 billion years from now. So it's going to be a kind of nasty time to be on Earth at that time, as the sun runs out of fuel and we're crashing into Andromeda. Next question.
Great.
Yeah, we got time for one more for Daniel, and then we'll move on.
All right. Well, so we know that the universe is a really, really big place. And folks want to know, specifically Bingo on YouTube is asking, how close to the center of the universe is the Andromeda Galaxy?
Interesting question, Bingo. It's sort of anti-intuitive, and probably I would be challenged to answering this right now. Maybe Jacqueline wants to take a shot at it, but there is no center to the universe. It's all just expanding, but we actually think right now that it's infinitely big and it's just getting bigger. So there is no center. Andromeda, if you're on Andromeda, it also looks like every galaxy is moving away from you except for the Milky Way. If you're on another galaxy, again, everything looks like it's moving away from you. And you would also measure a Hubble on a planet orbiting a star in any of those galaxies sees that same thing. No one's in the center.
Very cool. Now, we'll be hearing more from Dr. Stern near the end of the show, but our next speaker is also an astrophysicist here at JPL. Her research tests the CDM paradigm by connecting galaxy clusters to cosmological parameter tensions and alternative models of dark matter. Dr. McCleary is an active collaborator with the superpressure balloon-borne imaging telescope, SuperBit, project which will deliver space-like imaging at a fraction of the cost. Tonight, delving deeper into the mysteries of dark matter is Dr. Jacqueline McCleary. Hey, Jacqueline.
Hello, I'm Jacqueline, and tonight we are going to delve into one of the deepest, darkest mysteries there is. But don't worry, this cosmic mystery is only mildly horrifying. If there's one thing you should take away from tonight, it's this. 81.5%, about 4/5 of all matter is dark. By matter, I mean anything that seems to interact through the force of gravity. And by dark, I mean it doesn't appear to emit or absorb any light. This is where dark matter gets its rather eerie nickname. We know that dark matter has to be there because of the way it pulls on the matter that we can see, stars and gas and galaxies. Let's look at an example. Next slide. One of the most important clues to the existence of dark matter comes from how galaxies rotate, how they spin. What you would expect from normal physics is the scenario on the left. As you move further out from the center of a galaxy, the stars and gas move more slowly, in the same way that Pluto orbits the sun more slowly than the Earth, but Mercury orbits faster. However, in the 1970s, astronomer Vera Rubin found something very surprising. Galaxies rotate like the one on the right. It doesn't matter how far out you go from the center, the stars and gas move at the same velocity. So rather than spinning like the solar system, galaxies rotate more like a frisbee or a record. This was a huge surprise. This type of rotation is only possible if galaxies are embedded in a vast cloud containing much more matter than just visible stars and gas. About 5 to 10 times more matter. So this was a huge surprise when it was first discovered, and it's not the only line of evidence we have. Let's look at another way. Next slide. This is an image of an object designated MAX G1206.2-0847, which we will call MAX G1206 for short. This is a galaxy cluster, a structure that consists of hundreds of galaxies all located in the same place. Most of the galaxies that you can see in this image aren't actually part of the cluster, they're behind it. And if you look closely, you can see all sorts of weird stretching and curving of those galaxies, and specifically around the center of the image. This isn't an accident. This is happening because MAX J1206 is so heavy, it's actually warping the fabric of space-time, bending the light from the galaxy sitting behind it. Astrophysicists like me weigh galaxy clusters by carefully measuring the shapes and positions of these warped galaxies. Every time we look, we find a mass far larger than what you'd get if you just tallied up the cluster's stars and gas, about 5 times more. There's literally more to galaxy clusters than meets the eye. They're mostly made of dark matter. The blue glow on the right side of the image is a visual representation of this halo of dark matter for cluster MAX J1206. All galaxy clusters have halos of dark matter like this. But it's not just in galaxies and clusters. Dark matter even affects how galaxies are arranged in the entire universe. Let's take a look at the next slide. So this is one of my favorite pictures in astronomy. It comes from the 2-degree field galaxy redshift survey, an incredible scientific effort that pinpointed the 3D location of almost 250,000 galaxies, their position on the sky, and their distance away from us, their redshifts. In this picture, we on Earth are sitting at the center of these 2 cones, looking outwards into space, and each one of those tiny white dots is a single galaxy. What this image is showing us is that galaxies aren't randomly distributed in space. They're organized into a beautiful, if slightly creepy, cosmic web made of strings of galaxies, called filaments, with empty spaces or voids between them. Now, astrophysicists are a curious bunch, and we want to know, how does this structure come about? So we build giant computer programs called simulations. Next slide, please. To explore, we build these giant computer programs and let them predict what the universe should look like. You can think of these simulations as a universe in a box. They include all the physics we know: gravity, the way fluids move, how stars and galaxies form and evolve, and most importantly, the presence of both regular and dark matter. This image is a snapshot from one such simulation, Illustris. Yellow dots represent galaxies, the blue shows dark matter. You can see the same structure of voids and filaments, the same cosmic web, emerge as in the real data. To make this picture even more clear, let's look at these 2 images side by side. On the left is the same image of the Illustris simulation I just showed you, recolored to black and white. The right is that same image of the cosmic web from the 2-degree field survey. Without dark matter, the pattern of filaments and voids in simulations on the left would not match the observed reality of the cosmic web. There would be too much empty space, too many voids, and the filaments would be too far apart. Dark matter is literally the scaffolding holding the universe together into this beautiful web. All of these lines of evidence that we've discussed, so cosmological simulations, the way galaxy spins, galaxy clusters, and many other lines of evidence are telling us that we can't explain the observable universe without the existence of dark matter. But what exactly is dark matter? Well, our best guess right now is that dark matter is some sort of undiscovered particle. Next slide, please. Many candidate particles have been proposed with exotic names like weakly interacting massive particles, dark photons, dark neutrons, axions. These weird unseen particles are collectively termed the dark sector. And it's where we think dark matter is hiding. Dark matter could be any one of these, or several of these, or something else altogether. Experiments to detect dark matter particles are currently underway everywhere, from the deepest underground mines, to particle accelerators, to satellites in orbit. Yet its exact nature continues to elude us. Dark matter is one of the great cosmic mysteries, and just one of many in our galaxy of horrors.
Very cool. I'm sure there are some great questions out there. Thalia, what are the people? I think dark matter is always a hot topic. People always want to know more about it.
I like
what are they
that.
asking today?
Yeah, so we have a lot of curious minds out there. Folks want to know a little bit more about dark matter, so let's see if you can help them out, Jackie.
So do we. So do we.
Yeah. All right. Well, let's see if we can answer this question. Craig on Facebook is asking, have we measured the mass of dark matter?
So that's an excellent question, and it's essentially related to what sort of a particle could dark matter be, if it even is a particle. So we know that there has to be a certain amount of extra mass hidden from eye in the universe. Like I said before, about 4/5 of all gravitationally interacting matter, but you could have massive and massive and massive quantities of an extremely light particle, or a somewhat reduced quantity of a slightly heavier particle. like weighing what dark matter is, what a dark matter particle would be. Whoever does that gets a Nobel Prize.
Very cool. So we'll talk more about Nobel Prizes and dark matter in just a little bit, but we want to get to our final speaker, and then we'll bring everybody back and we'll do kind of a group discussion. Because a lot of these questions you're asking, we can get multiple answers from all of our speakers, so it'd be great to get everyone involved in those. But our final speaker, an exoplanet scientist at NASA JPL, she investigates the atmospheric circulation or weather of exoplanet atmospheres and what we can learn about these processes from telescopic observations. Here to depict the menace of weather on exoplanets is Dr. Tiffany Kataria. Hi, Tiffany.
Greetings, Earthling. I mean, Brian.
I love it.
So let me, the better to see these posters, I'm going to take my glasses off here for now. So this evening we've already talked about scary collisions. We've talked about scary dark matter. And so I wanted to close it out by talking about scary planets. These posters that have been that were developed just a year ago that I helped inform on, they certainly look scary, but I want to talk a bit about what science actually makes these posters so scary. So we're going to walk through all three that exist out in the world right now. So you can go home and you can download it from the comfort of your homes. So the first one here is the Reigns of Terror on HD 189733b, rolls off the tongue. This is a planet called a hot Jupiter. And so the reason it's called a hot Jupiter, it's because it's roughly Jupiter in size, and it's hot because of its temperature. It orbits its parent star roughly every 2 days. So it's actually 10 times closer than Mercury orbits our sun. So that means it experiences temperatures of something like 1,600 degrees Fahrenheit. So you think Earth is hot. Certainly in LA it's hot, but this is a hot environment. And so this planet was actually found using the transit method. And so this is a common technique used to find exoplanets. And so you're actually staring at the star over time. And when you see the light dimming over time, you can infer that a planet is there. So if you're observing as it transits, you can infer that the planet's there. So a bigger planet will block out more light. A smaller planet will block out less light. So that's how we know that this is a Jupiter-sized planet. So this planet is particularly scary because of these reigns of terror. And so given these high temperatures, the planet is so hot that the rocks and minerals we find on Earth are actually would vaporize in these atmospheres and form clouds. And so we can think of sands or glass. Silicates is commonly what are these clouds are made of. And so that's why we call them here clouds of glass. And that's actually what makes their observations that actually suggest that this planet's atmosphere is blue. That's due to that glass. Not only does this glass appear in the sky, but it's actually being blown about by these really howling strong winds of roughly 5,000 miles per hour. And that's, again, due to how close the planet is to the star. It actually has a permanent day side and a permanent night side, which is what this artist's conception is showing you here. So given that geometry, you're actually this planet experiences these very, very strong winds. So definitely not a planet you'd want to go visit. So let's go to the next slide and the next planet. So this one is Flares of Fury on AU Microscopii, or AU-MIC-B. This planet is roughly Neptune in size. It orbits its stars every 8 days, roughly. The system itself is actually only 32 light years away, so it's actually one of the closest systems to us, so frighteningly close, one might say. And this system is particularly scary because it orbits the star, or rather the planet, orbits a red dwarf star. That's what the type of this star. And so a red dwarf is about half as cool as our sun. And what's notable about it is, given how young the system is, it's actually undergoing quite a lot of magnetic activity or radiation. So it's emitting this high amount of radiation that then the planet is encountering. And so again, a very scary environment to take place in. Not only this, but the system is also known to have a debris disk. So viewed from Earth, we actually see it edge on. And so a debris disk is basically what a disk full of debris. In this case, it's dust. And so these are actually ideal environments to look for planets because you've got all this material making those planets. And so this was kind of a nice confirmation of what was always suspected, that, you know, these are good places to search for planets. And this particular one was found using the the Transiting Exoplanet Survey satellite. So this is an all-sky transit survey. But yeah, another scary planet that you wouldn't want to go visit. And finally, the last slide, our third poster. This one I would say is the scariest of all. You know, this one was really made for the series. This is a pulsar planet system. There are actually 3 planets in this system. It's actually one of the first exoplanet systems ever discovered. This PSR B1257, again, rolls off the tongue. A pulsar is a rapidly rotating star that emits a ton of electromagnetic radiation out of its poles. That's what this image and the poster is showing you. And so it's called a pulsar because it emits that radiation at millisecond pulses, roughly. And so you know the period over which the electromagnetic radiation is being emitted and viewed towards Earth. And so any anomaly, any scary deviation from that pulse tells you that there might be a planet there. And so in this case, there are actually 3 planets in this system. I should start by saying the star itself is called Lich, which Lich, if you look it up on Wikipedia, you'll see it's an undead creature that's known for controlling other undead creatures by magic. So again, totally scary to begin with. The 3 planets are actually named also scary creatures, Draugr, Poltergeist, and Phobator. Draugr, the planet A, is actually half the mass of Earth's moon. So really, I would say this is the scariest of all planet systems. It's really, made for Galaxy of Horrors poster. So yeah, with that, I'll take some questions.
All right, Tiffany. So there are tons of questions being asked right now.
Lots of scary stuff out there.
Yeah, there are. There are a lot of scary worlds out there. But Allison on Facebook wants to know, how on Earth did those planets survive a supernova?
That's a great question. And I mean, the answer at the end of the day is we don't really know. I think there are a couple of theories being kicked about. One that I saw that was being kicked about was that maybe these planets formed after the supernova. Maybe there was a second stage of planet formation after these 2 white dwarfs merged and formed those planets. But there are any number of scenarios that maybe could have produced those planets. Yeah.
All right. And Dan on Facebook would like to know, the hot Jupiters, are those mostly gas? Do they have any, terrestrial components to it?
So yeah, given that it's a Jupiter, a hot Jupiter, it's mostly gas, hydrogen and helium gas. There's probably some sort of core there that might be made of rock, but we can really only see the atmosphere. So, but any inference we're really making about these faraway systems are based off of what we know within our own solar system. So the better we know Jupiter, the better we can understand hot Jupiters.
All right, let's bring everybody back in here. All of our speakers are brilliant and can talk about many different topics. Tonight, I asked them kind of all to pick something that they really felt passionate about and wanted to talk about. But we're going to open it up because some of your questions may have an answer from every one of our speakers. So, Thalia, it just seems like everybody's asking a lot of questions out there today. Let's keep hearing what they're talking about. We can do this for a while. Yeah.
Yeah, so we have tons of great questions. Let's see. So Cody wants to know, I think going back to the exoplanets, Cody on YouTube asks, is there really a planet that rains glass sideways at 5,000 miles per hour?
Yes. The answer is yes. So this particular system actually is one of the best characterized hot Jupiters we know about. That is to say, a lot of telescopes have been observing this system, and so we understand quite a lot about its atmospheric properties. So we know that there's water in the atmosphere. We know we have a good handle on how hot it is, and so and as I mentioned earlier, this blue color, this actually isn't really an artist's conception. It's actually derived from real science, and so in this case, given how the particles in the atmosphere on HD 189 scatter, that actually makes it blue to the naked eye. So it was observed to be blue based off of observations. And so Yeah, so given that, given the simulations that I run to compute the 3D winds in the atmosphere, all simulations that I have run and other exoplanet scientists have run show that these winds are very likely. And in fact, they're actually other observations that have made direct measurements of those winds. So you can measure essentially the Doppler shift of a molecular line. So if you look at water in the atmosphere and you measure the Doppler shift of that molecule, you can actually derive what the wind speed or the rotation of the planet is. So it's all very cool, all very sophisticated analyses that can lead to these really startling conclusions.
All right, thank you for that. So we heard earlier that the universe is expanding, but Pete on Facebook asks a very great question. What is the universe expanding into? And I don't know if Dan or Jacqueline, you want to take that one on.
So,
Jacqueline.
all right, let's do this. So that is an awesome question. And I think you almost have, the best answer I could think of was a philosophical one. So if the universe is all that is, does it make sense to think about distances outside of it? I think perhaps bringing it back down to earth a little bit figuratively, it's unknowable. Our laws of physics are defined for the universe that we see. Anything outside of that universe, we don't have the means to formulate theories or test theories. We can only speculate. So the answer to your question, which is a very good one, is unclear, and I don't know if we'll ever know.
The fear of the unknown.
That was a very great question.
That was a great question.
All right, so Melissa on YouTube wants to know, are there multiple universes? I don't know who wants to take this one on.
I mean, why not? There's a bunch of there are a bunch of theories, a bunch of cosmologies that suggest that we do have multiverses, that our universe is a bubble in some giant foam of many such universes. I think we're still looking for experimental predictions of those theories. And once we have experimental predictions, we can start to assess whether or not this is true. It's certainly a really intriguing possibility. I like the notion of a foam of universes.
There was a prediction that you might get this ring in the cosmic microwave background radiation of different temperature as two multiverses collided together. And there was a paper, I'm not sure how many people really think that's the end-all answer, but there was a claim of maybe seeing a ring that could be from that, or it could just be a statistical anomaly. But
yeah,
they forgot to clean the mirrors. Yeah.
All right, so we have some other great questions in the chat. A question that has come up twice now. Kashvi on YouTube asks, is dark matter present in black holes?
Wow, so many good questions. So I think, how would I think about this? So at the very center of a black hole, you have a singularity, right? You have an area of effectively infinite density or nearly infinite density. And I think at that point, I don't know if you can talk about dark matter as dark matter or regular matter as regular matter. Certainly, say dark matter bound to gas or stars or whatever that get pulled into a black hole, the dark matter, if dark matter is indeed a particle, those particles will get accreted into the black hole, same as anything else. So I suppose the answer is yes.
All right, and we have some more really great questions in the chat. Let's see, Cody on Facebook asks, what evidence is the multiverse theory based on?
Dan, you want to take that one?
Sure. I'll start. You can jump in. But there are, we measure things in our universe, like the mass of a proton, the charge of the electron. There's various parameters that we can't predict with current physics. And so one thought is that maybe when the universe and the Big Bang happens, kind of dice get rolled and those parameters get set to some value. Maybe even how many dimensions the universe is one of those parameters. And as soon as you start thinking about that as a solution for trying to understand what these parameters are, then it naturally leads to the idea, well, maybe there are other dice being rolled with other parameters happening. And so there might be a whole other set of multiverses. As Jacqueline hit on, though, this is sort of balancing it's whether it's science where there's a theory with a predictable hypothesis is unclear. It might be more philosophy and not have testable hypotheses.
All right, very interesting. I think I have a question for Tiffany. MK3GTX on YouTube asks, does the number of stars in the system affect how many planets are formed? And do binary star systems have more planets?
That is a great question. So I should start by saying that we do, maybe MK knows this already, that binary star planets systems do exist. The Kepler Space Telescope has found some. I think there's anticipated to be more with TESS and other future surveys for exoplanets. So let's see, that was a multi-pronged question. So do more are more planets expected around binary systems? That was one part of the question, right?
Yeah. So the first part is, does the number of stars in the system affect how many planets are formed?
Yeah. Yes. So I think so. Yes. So there have been a number of simulations of the orbital dynamics of how planets and multiple stars would interact, and basically. When there are two stars present, that means you're dealing with a three-body system, and that creates a lot more instability. And so in a lot more cases, you might expect some planets to be actually just ejected from the system, so just completely kicked out. And so the system has to be really stable to be over the long time period such that the planet can survive and gain an atmosphere and do all those other things. And so given those probabilities, it's perhaps less likely that multiple planets would exist around a binary star system. That's not to say that there are probably situations where that could happen, but it's far less likely. The second part was whether or not there would be sorry, can you repeat the second part of the question?
Yeah, sure. So if binary star systems have more planets than, I guess, single star system.
Than single star systems. I think the answer, I don't know if we know quite yet. I think, TESS, this all sky survey, will really serve to answer a lot of those questions. I mean, so much of what we've done for transit science, that's kind of where I'm thinking, has been for single star systems. And so I think, the more complete we have of a survey, the better we'll know the answer to those sorts of questions.
All right, great. Let's see. Ian on Facebook asks, is it possible that dark energy is caused by white holes expanding space-time without necessarily spewing out matter? I don't know if Jacqueline or Dan, you guys want to take this one on.
Jacqueline.
So again, great question. Dark energy is something that's inferred, right? We see a whole bunch of phenomena in the universe, starting with supernova acceleration, and on from there. And what it actually is, we're not sure. So certainly white holes or something like that's a possibility. Some of my other colleagues at JPL will probably have more to say about that. People are also looking for deviations from general relativity, areas where Einstein might have been wrong, in order to explain dark energy. So the best way we can tell, the tool that we have is kind of the cosmic web stuff that I showed before. It's looking at the positions of galaxies, how clumpy they are, how that clumpiness changes with time. And this tool, this is a tool that we can have to try to infer how the universe is changing with time, how dark energy is driving the expansion, and then from that try to eliminate classes of models like white holes, say.
All right, thank you. Let's see. Kai on YouTube asks, will the universe have a limit to where it expands? And if it does, will there be a great compression? Dan, do you want to take that one on?
Sure. It's a little scary that this is on even much longer time scales than the collision I talked about. But it seems like the universe, or actually the universe we know right now, that expansion is accelerating. So the universe is getting bigger and bigger, and that's just expected to continue and continue. And so as it expands, you'll stop being able to see distant galaxies because they'll be beyond your horizon. As it expands, it cools. And so we're not looking towards a crunch. We don't, 20 years ago, we thought maybe it would expand and then collapse back down. At this point, the current theory is it's just expanding and expanding and accelerating the expansion. And so it's this cosmic cool down. What's the fun word for it? Jacqueline, do you know?
The heat death of the universe.
Yeah.
That's what keeps me up at night. Like, oh.
But that's for like 150 billion years from now where it starts getting ugly.
Yeah.
All right, so we have one more question from Amaya on YouTube. And she's asking, how do you guys sleep at night knowing that all these scary things exist in the universe?
To which I would answer, we're astronomers and astrophysicists. We chose our line of work so that we wouldn't have to sleep at night. So there's your answer, at least from me.
Ditto. I'm using the Keck telescope Saturday and Sunday night.
I sleep well at night because it means we still have stuff out there to go and discover and learn. If we knew everything, what would we be doing here?
Good answer.
Those are such great answers. Something that I do appreciate and I love about all of you is not only your passion that you bring to these and the joy that you bring to what could be pretty downer topics, but also and I think this is a good lesson for any students out there, your willingness to say, we don't know. We're pretty smart and we know a lot of this stuff and there's still things that we don't know, and that's what keeps you going at night. It's always wonderful to see that. We do have time for one last question. So Thalia, what's this last question?
All right, yeah. So MK3GTX on YouTube asks, again, this really great question. What are your favorite instances of science fiction that turned into real discoveries?
You've stumped everybody.
Well, I think, Brian, you're on the hook for also answering.
Yeah, I think Brian should answer too.
So what's a science fiction thing?
Can you repeat the question for me?
Yeah, sure. So what are your favorite instances of science fiction that turned out to be real discoveries?
Oh.
I think
if no one has an answer, I think I might have.
Okay, so
I have an opposite one. You go.
Yeah. Thalia, you should go.
All right. So we actually have a poster about this, and it's a planet called Kepler 16b. And we've nicknamed it Tatooine because it is a planet with 2 stars. So it has 2 sunsets.
I took my answer to Leah.
Yeah. So
this is Tiffany.
I have like an extra nerdy one. I remember as a kid watching Star Trek, the original series, and it's before cell phones were super super common everywhere, and also seeing the tricorders that Dr. McCleary would use to scan everybody. I thought, wow, what incredible technology. And here we are, not so many years later, and your phone basically is a tricorder. It's a portable long-range communication device. And I think that having cell phones around is it's a pretty wild science fiction dream come true, I think.
I have another one from Star Trek, but on the opposite side. I have another one from Star Trek on the opposite side where it was not the first series, it was a later one, but they were flying through the galaxy and they ran into a cosmic string. And that's something that people have worked on for a while, but we now don't think cosmic strings exist. So it was sort of something in sci-fi that was around theoretically for a while, isn't popular now. Maybe 20 years from now, that will come back into popularity, and that will be like Tatooine, where they saw it ahead of time on Star Trek.
Tiffany?
I don't know. There's so much interesting science fiction out there about planets. Just the array of exoplanets that we've discovered. Hot Jupiters, for example, were never theorized before they were discovered. How does a Jupiter-sized planet survive so close to a sun-like star? That was not something that people ever thought about until they found the first hot Jupiters. And so, any scary planets that you might have seen in your favorite sci fiction movie, there probably actually exists a planet like that out there. And that, to me, is a pretty incredible thing.
And if you all are going to make me answer, I think what we're doing right now is actually my favorite thing. The fact that we can have your three brilliant minds here talking to on screen, it's not a telephone, that we can have this conversation with so many people all over the world right now. I think that's pretty amazing. And yeah, maybe a little Jetsons, but who thought we'd be here right now? But I'm still waiting for my flying car. And that is all the time that we have for tonight. I really want to thank our speakers, Dr. Tiffany Kataria, Dr. Jacqueline McCleary, and Dr. Daniel Stern, for their expertise and their energy. Now, next month, we'll be discussing how failure helps us succeed, the agony and inspiration of defeat. And as our speakers put on their alien and rocket man sunglasses, I'd like to thank Thalia and everyone behind the scenes that make these talks possible. And a big thank you to all of you who join us every single month. Remember, the Galaxy of Horrors posters are available to download for free through our website, and you can find the link in the description. The Exoplanet posters are up there now, but keep an eye out for the Astrophysics batch that is going to be coming out as Halloween approaches. And as a special treat this Halloween season, as promised, we're going to end our show with our Galaxy of Horror videos. Stay safe, stay kind, and we'll see you next month.
The night sky, full of stars. For eons, human beings have gazed up at its tranquil beauty, taking solace in the peaceful stillness of this vast and eternal cosmic cornucopia. And yet, all the while, lurking beyond our solar system, among the billions of stars and the exoplanets that orbit them, is another sort of Milky Way altogether. A far more sinister space. A place only sophisticated space telescopes and imaging processes can reveal. A place of unequaled terrors. Come with us now, if you dare, and discover the Galaxy of Horrors. Feel the rains of terror, the killer you never see coming, with winds of up to 5,400 miles per hour and torrential rains of glass, blowing sideways. The weather here is deadly, and don't let its cobalt blue color fool you. This hazy, blowtorched atmosphere is riddled with silicate particles, making this an unearthly death trap no mortal would dare want to face. Or discover the zombie worlds that exist in this most inhospitable corner of the galaxy, the Poltergeist planet, one of 3 dead planets shambling through the twisted magnetic fields of their corpse star Lich, which is itself the collapsed core of an exploded star. But Despite its demise, this undead star spins twin beams of radiation that could incinerate a spaceship foolish enough to venture too close. Even if you could make it to the surface, your nightmares would continue as the radiation from the zombie star rains down on planet Poltergeist, as well as her neighboring dead worlds of Draugr and Phobitor, creating sickly irradiated auroras to light up your certain death. These are just a sampling of the terrible, unwelcoming worlds that inhabit our galaxy of horrors.